Chapter 7, Section 2 is entitled Mean, Median, Mode, and Range, and our objective in this section is to find the mean, the median, the mode, and the range of a particular data set. We'll start off with the vocabulary that we'll use throughout the section. We'll start with the definition of mean. Mean is the sum of the values in a set of data divided by the number of data items in the set. The sum of the values in a set of data divided by the number of data items in the set. Median is the middle number, or the mean, average, of the two middle numbers in an ordered set of data. The middle number, or the mean, the average, of the two middle numbers in an ordered set of data. Mode is the number or numbers that occur most often in a set of data. When all numbers occur with the same frequency, there is no mode. The number or numbers that occur most often in a set of data. When all numbers occur with the same frequency, there is no mode. Range is the difference between the greatest and least values in a data set. The difference between the greatest and least values in a data set. And an outlier is a value much greater or much less than the others in a data set. A value much greater or much less than the others in a data set. So let's start with the first example where we're asked to find the mean, the median, the mode, and the range of the data set. Now, one of the things I would typically do when teaching this, and you'll see me do this in problems throughout, but maybe not right away as I would do, is I would normally put the numbers in order from least to greatest to begin with. It's not needed for every component they're asking for there, but it is needed, for instance, for the median, and it's one of those things that does make life a little bit easier to do right away. But we'll start with the mean. In the mean, what you need to do is add up all the numbers to start. So as you can see, they're adding the 4, the 7, the 8, the 2, the 1, the 2, the 4, and the 2 to get 30. To find the mean, then what you do is divide by how many numbers are on the list. And as you can clearly see, there are 1, 2, 3, 4, 5, 6, 7, 8 numbers on that list. So they're dividing by 8, and when they do 30 divided by 8, you get 3.75, meaning that the mean is 3.75. The median is the middle number when the numbers are arranged in order from least to greatest. So as you can see, we have our list of numbers there, and they are in order from least to greatest. And as I count in from the outside to try and derive my middle number, I see that there is actually two middle numbers, 2 and 4 in this case. Now, if there's a perfect middle number, just one middle number, that is automatically the median. But when there are two middle numbers, you simply take those two middle numbers and average them, which would mean in this case to divide by 2. So 2 and 4 added up makes 6, and 6 divided by 2 is 3. So the median is 3. Next, we'll find the mode. The mode is the number that shows up most often on the list. And as you can see from the red underline there, 2 shows up on the list quite a few times. So the mode is going to be 2. There can be more than one mode. If there was another set of numbers that were out there 3 times as well, that could also be part of that answer. There can also be no mode at all. If no number shows up more than once, then there would be no mode. The range is the difference between the biggest and the smallest numbers on the list. So in other words, what I'm asking you to do is subtract big minus small, or 8 minus 1, and you'll yield a range of 7. Number 2, the line plot shows the number of miles each of the 17 members of the cross-country team ran in a week. Which measure of central tendency best describes these data? Justify the answer. What they're talking about with measures of central tendency is they're talking about which of those calculations, mean, median, or mode, comes closest to representing most of the numbers. Which one is around most of the numbers? Usually range is not going to be the answer, which is why I excluded it previously when I said mean, median, and mode, because the range is when you subtract the big and the small. Those other 3 are calculations that should somehow be around the numbers that are actually being represented. So as you can see, I converted the line plot into numbers at the bottom of the screen. Remember, every x represents a number. So for instance, the 5 x's above the 4 means a 4, 4, 4, 4, 4, which is why you see 5 4s in the calculation. So when I added up all those numbers and then divided by 17, since there were 17 x's, I came up with an answer of 9 for the mean. In this case, the mean best describes the data set because the data is clustered fairly evenly about the two areas. As you can see, that 9 is kind of in that set there of numbers. There's about the same number beneath it as there are above it, so the mean is a good representation. The median here, the middle number, is going to be 6. As you can see, the arrow points that out. In this case, that 6 really favors all the numbers on the low end, but doesn't really show the numbers on the high end. So we're going to say the median does not best describe the data set because many values are not clustered around the 6. Again, most of those numbers on the low end, but those numbers on the high end, 14s, 15s, and 16s, aren't in that area. As far as the mode goes, the number that shows up most often is 4, and we knew that because that was the tallest bar of x's on the line plot. The 4 is, again, way down in that low end of the number set. It really doesn't represent the 14s, 15s, and 16s well. It focuses more on the one data value, as it says, and does not describe the data set. So again, when you're trying about central tendency, look for the number that best represents all of the numbers, and that's probably going to be a winning answer. Oftentimes you'll find, and this, I think this example is kind of an exception, just simply based on the numbers they gave us, but a lot of the times you'll find that there may be two number sets there that actually work, meaning it could be the mean and the median, or the median and the mode might actually be both acceptable answers for the best measure of central tendency. It will not automatically always be the mean. Number 3, the data shows Sarah's scores for the last 5 math tests, 88, 90, 55, 94, and 89. Identify the outlier in the data set. Then determine how the outlier affects the mean, the median, and the mode of the data. Then tell which measure of central tendency best describes the data with the outlier. So an outlier is simply the set in the number, or maybe more than one number, that doesn't match up with the rest of the set. As you can see, if we're talking about test scores, Sarah's got a lot of A's and B's, but then all of a sudden she gets an F. That F is not what she normally does, so that's the outlier in this set. The 55 is a number that just doesn't match up with what she normally does. So we're going to go through and calculate all these things without the outlier, and then again with the outlier, and compare what happens. So as you can see, we'll start with the outlier on the right side there. So we're going to take, just find the mean, add up all the numbers, the 5 numbers, and divide by 5. So we have 416 divided by 5, which is 83.2. Now, let's think about what happens here. If I take out a low score, what's going to happen to Sarah's scores and all? Well, if I take out a low score, the grade should go up. And as you can see on the left side there, without the outlier, I'm just adding up the 88, the 90, the 94, and the 89, not the 55, because that's the one we're getting rid of, and now dividing by 4, because there's only 4 numbers in the set, and all of a sudden her average is 90.25. Median is a little bit simpler. Again, the median is just the middle number when they're in order from least to greatest. As you can see, with the outlier, the middle number is 89. In this case, when I throw out the outlier, there's actually 2 middle numbers now, 89 and 90. Again, when there are 2 middle numbers, you have to average those numbers. So I'm going to take 89 and 90 and add them together, which is how I get 89.5 after I've divided by 2. So as you can see, the median, even though it didn't change a drastic amount, it also went up. If I threw out a number on the high end, all right, the median should then instead go down normally. All right, it could stay the same if there's multiple same numbers in the middle, but normally it would tend to go down. Here's the mode. Remember, the mode is the number that shows up most often, and each of those numbers only shows up once. So even when I throw out the odd dot, it's still only there once. So either way, there is no mode. So what happened? Adding the outlier changed the mean by 7.05, quite a bit, and the median by 1/2, and the mode did not change. Now, the other question they asked is which number best describes the data with the outlier? And in this case, it would be the median. The median best is centered around most of the numbers in this case. Okay, so in our final question here, they're asking us to find the mean, the median, the mode, and the range of the data set. So again, as you can see at the bottom of the screen, something you've become accustomed to is me putting the numbers in order from least to greatest. And once I put the numbers in order from least to greatest, it's definitely easier to find certainly the median. But for the mean, we're going to add up all the numbers, 1 plus 2 plus 3 plus 4 plus 5 plus 5 plus 6 plus 8, and divide by, in this case, 8. Why 8? Because there's 8 numbers on the list. So I've got 34 divided by 8, which is 4.25. Again, the median is the middle number when they're in order from least to greatest, and in this particular problem, there are 2 middle numbers, 4 and 5, so you're going to want to add those up and divide by 2. 4 plus 5 is 9, and 9 divided by 2 is going to give me 4.5. There is nothing for the bottom of the page for the mode because remember the mode is simply the number that shows up most often, so there's no calculation required there. And as you can see, 5 is on the list most often, so 5 is automatically the mode. And the range is the difference between the biggest and smallest numbers on the list. So I'm subtracting, in this case, 8 minus 1, and 8 minus 1 yields 7. So the range is 7.